Okay guys, this is going to be a nice short and sweet lesson on equations as point testers. So what we can do is we can tell if a coordinate pair is on a graph of an equation by just plugging that coordinate pair or that x and y value into the equation. So if I were to ask you, is the point 6, 0 on the graph 2x plus 3y equals 12? Well, it's very simple. We just take and plug those numbers in. Since 6 is the x value, I would put that in for x. 0 is the y value, and I'd throw that in for y. So let's see. 2 times 6, which was my x value, plus 3 times 0, which is my y value, does that equal 12? Well, 2 times 6 is 12, plus 3 times 0 is 0. Does 12 plus 0 equal 12? Yes, it does. So we can say that the point 6, 0 is on this graph. What about -1, 8? Try it on your own and push play when you think you have an answer. Let's see. So we should have written 2x plus 3y equals 12. Since x is -1, that would be 2 times -1 plus 3 times 8. Does that equal 12? 2 times -1 is -2, plus 8 times 3 is 24, and I can already see that no, that's not going to work out. So we would say that no, -1, 8 is not on that particular graph. Pause the movie. Make sure you have these examples copied into your notes. So here are a couple key vocabulary words we need to know. We use the equation as a point tester. So you might hear the book or Miss Garcia referring to the equation as a point tester. To use a point tester, we simply plug the points in to see if they are true or false. If they're true, we call them pass points, kind of like they pass the test. They make the equation true. If they're not, we call them fail points. Pause the movie and write these vocabulary words into your notes. So let's look at this particular problem. Using pass-fail points to determine the graph of y equals -3. Now this gets a little tricky because there's really no x value that's going to change this. In order to make this equation true, I would need y equals -3 so that -3 equals -3. What that means is that no matter what value of x, y is going to have to be -3. So if x is -5, y is -3. If x is +5, y is -3. If x is 2, y is -3. So this turns out to be, sorry for the bad line, a horizontal line at y equals -3. Copy this example into your notes. Try these two last problems on your own. Bring your answers to class tomorrow.